Today we're going to talk about concepts of workflow systems. So you know already that a workflow is a combination of a large number of batch jobs and files into a very large concurrent program. So let's look at a simple example of a workflow. Suppose that I have a single file A, and I have a program that's going to process it and produce file B. We'll just call this program 1 for a shortcut. Now this right here, this is a single batch job. It has some input files, it has some output files, and that's one unit that we can send off to a batch system for execution. But what if we have a large amount of work that happens to be done? I don't just have one batch job that needs to be run, but suppose after I run this job, a simulation, I'm going to have to do something to analyze the outputs. Maybe I'm going to take this file B and feed it to another program 2, which is going to create an output C. And I want to feed that same output to a program 3, which is going to produce a file D. And furthermore, suppose I don't just have one set of programs to run, but I want to repeat this whole process thousands of times in order to simulate and analyze a large amount of data. So this is a workflow. It's a large collection of jobs and files that represent a large-scale parallel program. Now let me observe a couple things about this workflow. Number one, there's some concurrency expressed in the workflow. So this job here has to run before these two jobs. So we have to put those in the right order. But these two jobs can run simultaneously. And likewise, all of these branches of the workflow can run simultaneously as long as they respect the dependencies within each of those branches. Another thing is that a workflow could have thousands or maybe even millions of jobs in it by the time I multiply all these out. And it could consume an enormous amount of storage. If each of these files is measured in gigabytes, then this whole workflow is going to require terabytes of storage in order to execute correctly. Now, keeping track of all of those elements directly would be a big headache for a person. So we don't do this manually. Instead, we use a specialized program to process it. So what we're going to do is take this entire workflow and feed it to a specialized program known as a workflow management system, or WMS. And there are a variety of different workflow management systems that you can use, but they all operate according to the same basic principles. Now the job of the workflow management system is to take this entire structure and feed it piece by piece into a batch system. So suppose I have a cluster with a bunch of machines, and that cluster is managed by a batch system. Like we discussed earlier. Now, that workflow management system is going to look at one job at a time and feed it over to the batch system. And then it becomes the job of the batch system to decide where to place each of those individual jobs. So let's suppose the workflow management system decides to run this job first. It's going to give that to the batch system. And let's suppose that it decides to run it in this node right here. All right, so the batch system makes that placement. The job runs. Maybe it takes a long time to run. It could take hours. But eventually it will be done. And so the batch system will free that node. And the results will come back to the workflow management system. So here, the workflow management system took the file A, gave it to job 1, and produced file B. And so it makes a note of that. And now it can decide what to execute next. In this case, the WMS is going to dispatch jobs 2 and 3 over to the batch system simultaneously. So those jobs come over to the batch system. The batch system decides where to run it. And let's suppose they go here. Now those two jobs can run simultaneously. Again, they might run for hours, but when they're done, the batch system will release those nodes, send the results back to the WMS, which will make a note of what's complete. Now there's a couple things to note here. There's a degree of independence between the workflow and the batch system. The workflow management system decides in what order to run things, and also how many things to run simultaneously, but it doesn't control where they run, and it also doesn't control the policy of which user gets to run their jobs first. The batch system over here is trying to manage the whole cluster on behalf of multiple users, and it doesn't know about the workflow except for the jobs that it gets one at a time, and it gets to make decisions about where those jobs are placed, in what order they run, and how many users are able to get resources from the cluster. Now there's a couple other things to notice here. We've talked about the workflow management system handling the ordering of the jobs, but sometimes it also has to worry about the data in the jobs as well. Here I've given a simple example where each job just has a single input file, but commonly we see that many jobs in a workflow will all need the same data. So I'm going to add to my workflow here and add a big data set, R, for a reference data set. And let's suppose that all of these jobs here need to use file R as an input. Now at some level this is very simple because it's just a matter of ensuring that this file gets sent along with every job, so we have multiple copies of it. But think about what happens if R is very big. Suppose that it's 1 terabyte. Now every time we send a job off to the batch system, then we're going to have to load a terabyte of data off of disk and get it up to that job. Now 1 job at a time, that's probably okay, 2 or 3 or 10. But if we have thousands of jobs running simultaneously, then each one of them loading a terabyte, they're all going to conflict with each other and the system's going to have a whole lot of contention. So part of the job of the workflow management system is also to throttle the rate of job submissions so as to control the I/O load on the system. Now how does the workflow management system remember everything that's going on? Well, what it does is as it goes along, it creates what's known as a transaction log. And the transaction log is a record of every decision that the workflow management system has made. Which jobs have started, which jobs have completed, which files have been transferred, what the exit status of the job is, really everything that's going on. And this transaction log then can become a treasure trove of information for any questions that we might want to ask about the workload. So we can build quite a lot of tools that can read the transaction log and tell us about the performance of the system. They could tell us what's the average runtime of a job, how far to completion is the workload, how much data has been transferred, how fast are all the file transfers. And so this is going to be the source of information by which we analyze the performance of the system. Now finally, one more thing. The workflow management system can be thought of as a single point of control for an enormous amount of work to be done. We have here thousands and thousands of jobs, thousands and thousands of files consuming terabytes of storage, and we're going to go run them on a large number of machines. If we didn't have a way of controlling them, then the system could get out of hand and disrupt other users' work. What's very nice about the workflow management system is that it becomes a single point of control by which we can start a large amount of work. And if we decide we don't like that, it's not working and we want to stop it, it also becomes a single point of control where we can stop it. By sending the workflow management a signal, it can look at its transaction log, understand everything that's running, and instantly stop it on all of the cluster.